So I think spend your time, especially with the subject, obviously with the prep, just keeping along with the content, but then obviously making sure you just that project getting it done. But are you guys finding the project thus far? Any questions? Hello? All right, guys, I'm gonna wait till 25 minutes to, then I will continue with the lecture.
Doch. Masami inaendelea lugha nyingi. Masami.
All right, guys. Morning. Just please confirm if you can see my screen. Okay, cool. I see the thumbs. All right, so we're just gonna continue from where we've last left off to a degree. Just to have a quick recap on what we're looking at. We were looking at the different geometries and nomenclature of gears, and things like the dedenum, the addendum, the clearance, tooth thickness, the circular pitch, the pitch circle. We've looked at the module. We've also talked about the center distance, between the two gears. And so we're just gonna use that basis of geometry to look at a few more things which is of importance. Now, this particular thing is probably the most important for this subject. And then I'll mention other things like interference as well, backlash. I don't know if you guys can admit people, just admit them. Which is supposed to be part of getting, but I didn't see it in the textbook. So I'll just mention it to you, but obviously whatever's covered in the textbook will suffice for for what it's worth. Okay, so we'll be looking at something called the contact ratio. Now, what's not nice articulated within the textbook, so I'll just kind of explain to you what happens is we have two Spur gears mating, right? One obviously with the pinion, one we call the gear. And there's a particular point where these gears will meet, right? So if I would perhaps stop that image, I could just pause it at that particular image. Can I pause it over here? Okay, cool. Let me just pause it over here. That particular point over there is the so-called pitch point. It's a very important, yes.
Morning, sir. Sorry, I'm not sure if I'm the only person. I cannot see your screen.
I think, Liema, you probably have to refresh, I'm assuming, if everyone else cannot see. Okay, just start to refresh for me quickly.
Okay.
I'll wait on you. So okay, she will probably join and you'll hear from her. As I was saying, is that there's a particular point, and if I just do this, you'll notice the point is moving on some kind of straight line. This point, yeah. Now, this straight line of where the gears are meeting, right? It's to do with, and I believe it is covered in in mechanics of machines, but I'm not sure. But obviously, I'll reiterate. It's called the length of action, or the length of the length of it's a contact length, right? Length of contact. I'm not sure if you guys are familiar with it, which is basically the length of approach, which is this term over here, which is the first part. And then the second part would have been the arc of recess or arc of approach, or the length of approach and the length of reapproach. So as it comes in contact, and then as it disengages. So once it engages, once it approaches, and once it disengages, or what do you say? So if you sum up those two lengths, you essentially get these things. Now, there are obviously the modeling and the derivation of all of this is done. So what's fortunate for you is that, yeah, we have a complete equation to determine that length over there, right? Which is the length. But the reason why we need to know this length is because so we can find something called the contact ratio. And what the contact ratio is basically defined, it says the average number of teeth that are in contact when the case of meshing. And obviously that's important for us because we need to know how many teeth are in contact. And then to find that, you basically have to then use this formula over here. Now, that being said, is that if I could go to my slides, and I can always put up this lecture on which I've done some time ago, on basic getting, and you'll notice over here that in order to obtain this, like I kind of show you some of these equations. So normally you'd have something like, yeah, there we go. So one would be the path of contact, the path of approach, then it's the path of recess, and you sum them two up, and then you actually get the path of contact, which is that formula over here. Okay. After that, you take the length of path of approach and divide it by cos theta, which will give you the arc. Once you have the arc, you then simply have to divide that by, oh, I don't see it over here. Oh yeah, you take the length of the arc and divide it by the so-called pitch circle. And once you get that, you get the number of pairs in contact. So this one is a lot, obviously, a bit more detailed in how they break it down step by step. However, for you, in the case of designs, assuming that it was covered, that you just have to use this formula over here, right? So P would be your pitch. As you know, your RP, your addendum, your base circle plus the addendum. Obviously, cause of a pressure angle, which will be given. You do the same for the pinion and the gear. Obviously, then we have our center distance, tan. We have 20 degrees for our pressure angle, then again divided by P. And once we have that, you'll get a number ranging from anything from 0. I don't know, depending, 0.5 to around 2 and beyond. But the idea is this. If you need to get a value of around 1.2. And the reason being, it means that at least as a gear is rotating, at least one pair of teeth or tooth are in contact. If you get a value less than 1 or equal to less than 1, that means there's some interference happening, right? So that means the teeth are not mating. We'll talk about that. So what I'm saying is this value is a decision value in that you need to get around 1.4 to 2 for spur gears. And you'll notice that this is a similar trend when you're doing helical gears and when you're doing bevel as well. It's a very important ratio, this contact ratio. So it'll tell you how many teeth are in contact, and if it's too low, that means you got to adjust. So obviously that's what's important here. Okay, that's just about this. So we'll use this one, and then just reading off here. It says, I just snapped this from somewhere. It says if the contact ratio is 1, then there will be new pair of teeth coming in contact, just as the old pair is leaving, right? Which is basically what I was talking about. And there will be exactly one pair of teeth in contact all the time. So that's when your contact ratio is 1. This may seem acceptable, but this leads to poor performance. Since loads apply the tip tooths, you'll see that with the forces coming up. There'll be additional vibration, noise, and backlash. So it's good practice to maintain a contact ratio of 1.2 or greater, right? Again, most spur gears have a contact between 1.2, 1.4, and 2 as stipulated. And what it says there, a contact ratio between 1 and 2 means that at least 2 of the pairs of gear teeth are in contact during the remaining time 1 pair is in contact, right? A contact ratio between 2 and 3 means part of the time 3 pairs of teeth are in contact. So they're saying this is a rare situation with spur gears, but for helical gears, that is very common. And you'll see with the numbers there. And they say the contact ratio is very important because there's 2 particular reasons why. Is one, if 2 pairs of teeth if 2 pairs of teeth are in contact, the loading is a lot less. The stresses is a lot less. So that's the idea behind all of this. But you'll get to that. And you will talk about something called interference. Now, what I'm realizing in this textbook, there's no equations produced for interference. So I don't think not sure if you guys have covered this. But nevertheless, I'll just talk about. It's something important that you must know when you're dealing with gear systems. So they're saying here, so you've got a number of teeth on both gears, but one should also check for interference. And what it basically is, as you can see, there's when one teeth is into the profile below the other one's base circle. Then we have two base circles. And when that happens, the signal is high noise and there's material removal. And that's interference. And there's something in these mathematical ways you can check for that, which I'll come back to now. But to basically eliminate interference, it's to reduce the denim, you got to increase the number of teeth, you got to increase the pressure angle, you got to modify the tooth profile, and maybe perhaps increase the center distance. So there are ways of eliminating interference when it does occur. And like I said to you, there are equations, but it's not produced in this text for interference. But I don't know. I think the slides are separate, but there are two methods, and which is typically used. I'll just mention the one. It says we need to first find the actual path of approach and the max length of path of approach. And if the path of approach is less than the max length path of approach, then no interference will occur. So you can again see why the things I mentioned in the contact ratio are important, because once we're able to do it, we're able to identify if the gearing system will be operational. And these are all checks people do when it is design gear system. There's another one where we find the actual denim radius of the wheel and the maximum denim radius of the wheel. And if the actual denim radius is less than the maximum denim radius of the wheel, there will be no interference. So that's another check we can do for interference if it arises. Nevertheless, another one, very important, is backlash. And it says backlash is defined as the amount by which the width of the tooth or the space exceeds the thickness engaging to the measure along the pitch circle. Basically, there's some gap between that over there, right? And it says in general, backlash is the play between mating teeth, and it occurs when the teeth are in mesh. And it's another phenomenon you're going to want to look at, right? And so backlash is important there because it compensates for thermal expansion, for machining errors. And so you want to as well have backlash in your mind when you're designing gear systems. But like I said, these are all just fundamentals in gearing. I didn't mention undercut, but it's just something you should be aware of. Again, the septal backlash for gears is depending on the module. You can see over there what kind of tolerances we're looking at for metric gears now. What you want to have. So just a distance in place so that we make sure that we know that the gears are running smoothly. We're compensating for machining errors. We're also compensating for thermal expansion, depending on the case of where it's applied. So anyway, let's quickly get your books out. Let's try this one. And we're going to be doing a contact ratio type problem. And you'll notice there's quite a few of these problems. So yeah, treat them with respect. It might just come up. Is there any questions thus far? Any questions, students? Let's get the book out. Okay. Let's begin. After this one, we wanna I just want to get the formula for contact ratio for you. And then we're gonna move. Okay, so yeah, so fortunately in this case it's kind of given as one, you know what I mean, one big formula. Okay. So I'll take you through the steps and then you guys will obviously work through the list. So they're using this gear 11.7, figure 11.7. I think that's at standard gear. And then obviously they're giving you the number of teeth, they're giving your pressure angle, which is important, and they're giving a module. And luckily, we needed our addendum as well, which is 1 times a module, as per the table we did last week, which is this one over here. Yeah, I don't know if you guys remember that one over here. This one over here. Just pick it big for you. So just remember that all your dimensions are essentially coming from, from this over here. It's all standard, fortunately. Just put that over there. Okay, so let's quickly move. So what we want to compute is your using module. Oh, then you have your diameter of your pinion over the number of teeth of pinion, which is also equal to this over here. Okay, that's your gear. You could have called it small d, big D, whatever. You can call it whatever. So obviously we need the diameter. From the diameter we get the pitch. This over here, sorry, the base. From the base we have to add addendum. C is our center distance. Center distance we can also get. Our center distance is R1 plus R2, if you guys remember. Or we have another way using amount of teeth as well. And then obviously P, just to recap for you, I'll come back to P. So let's quickly get our RP and what is my RP and sorry, let me say it's my DP. Make it small DP, and what is my DG? I'm assuming we all know what we're getting here, right? The module is 10. So you can just shout out the answer for me once you've got it. Should be straightforward. Actually put up that image for you. Just that'll be your base circle getting now, right? Chat. Let me just check the chat. Okay. Aluve, yes. What did you get? Shaw, James, what did you guys get? So in this case, it should be 10 times 15, which would be 150. And then we have 45 times 10, which is 450. Of course, it's all in millimeters. And we just divide everything by 2, and we should get our that's, yes, I'm listening. 75, and this should be 225 millimeters. Okay, that's RG.
So are you doing any calculations? Because I just see slides here.
Okay, I see. I didn't share that. My bad. Cool. Yeah. Oh, that's why everyone's quiet. I see. No one said anything.
Yeah, we've been lost.
Yeah, just say I'm lost, so don't be quiet, man. I'm doing this one over here. Okay. So what I was basically doing here, or I just found your RP and your RG, which is your, for your pitch circle, basically. Yeah. Is everyone on the same page now? once that is done, we then obviously gonna compute your center distance. The objective here, we are finding the contact ratio. That's what we're doing over here. And if I get, where's my calculator now? What is my center distance there? You guys can find for me. Can't seem to find my calculator. But anyway, let me just use this. Oh, it's 300 man. Okay, cool. 300 millimeters. Is there any questions thus far before we proceed? Are we all on the same? We're all in the same frequency here. We need to get our base circle now. From a base circle, this is your pitch. Okay, cool. I'm assuming everyone is there. So if you remember from the previous one, I'm going to call it R. Let me call it RBP and big R, RBG, right? That's for your base circle. And for your base circle, it's simply the pitch cos that, and then your RG cos of the pressure angle. So you can quickly get that for me. I'm going to just show you again what it looks like, so you can actually see. So always have an image in our mind as we work. I'm assuming you guys can see now, right?
Yes, sir.
Perfect. Okay. Design is it's always all the sections are fairly boring, but I mean it's only useful once one actually uses it and applies and design again, then you'll see the fruit of doing this. But otherwise it's yeah. So again, that's your base circle. Your pitch circle will be there. Yeah, this one here. And then below your pitch is your base. And then above your pitch would be your tendon. So we're going to get that eventually. So we at the pitch, and then we're getting using that relationship over here, as you can see, with that 90 just there. So we're finding that base circle now. On the base, we're going to add the addendum, and then we're going to get. Okay, cool. Let's see what we get. Pressure angle was 20 degrees in this case. Typically, is always 20 degrees. You guys can just shout out the answer, then we can move on. See in the chat. Yeah. That. She went out again. Okay, cool. Thank you, Delicate. Yeah, well, guys, what do we get, man? What do you guys get? All right, what do you guys get? Cool. Charles says 70. Oh, I can't see both screens. 70.477. Cool. 70.477. And then for your gear, it's gonna be, let me have a look. 111 point. Wait, what is it? 431. I hope you guys are corroborating his answers because I'm not. Cool. So we've gotten the base, right? And what all we have to do now is add the addendum, okay? And fortunately for us, based on that table, we know it's going to be 1 times the module, which is this over here. So what we're going to do now, before that, we got to calculate our pitch circle, which I'm going to show you now. So that's our center distance. We've got that. We've got that. We've got that. Okay, this is not the same thing. I must be careful here. Yeah, this is your. Should just label something else because, yeah, but that's base. That's fine. Let me just do it like this. Just, oh, let me just mute that person's thing. Okay, mute all. Okay, cool. Where am I now? Oh, yes. And then our pitch circle, if you will recall, and I want to show you your circular pitch will be pi times m, basically. That's what it is. That's this. I'll show you now. Just so that you have a pitch in mind as well again. So it's this circular pitch. Obviously, you can see why that is important because that's where the right. And your circular pitch is simply, if you're thinking about, it's just pi times m. Okay, it's like an arc, and hence pi being the okay. So that'll come under there. So let's quickly compute the contact ratio. So the contact ratio will be 1 divided by pi times m. M is given as 10, right? Cos 20 degrees. Open the big bracket. And I'd recommend you to kind of do this piece by piece. I'll say minus 300. Oh, let me just go open this up. Just say 300 over here. And then you're going to say 10. I think I'm at my limit here now. Just erase this. Okay. So 300, then 20, and we just divide that by the pitch, like I said, which was pi times 10. Cool. So what you just need to do now for me is get this piece, right, plus that piece. So that's all over there, right? So RP is your base circle. You see what I don't like of this formulation because of these, yeah. And then you're just gonna add your addendum to that. So whatever you're gonna root your base circle, root base circle plus, right? And obviously, if you look at it properly, you notice that's like a hypotenuse type of thing. I can show you exactly where it is, but yeah. So let's quickly get that. Yeah. So don't confuse these two here. So these are two different things. So that should have been base. Let me just see the nomenclature if they've got it as base. Okay. That's the pitch circle. Just want to confirm something, guys, here. Oh, okay. They use P and G for the subscripts, man. So yeah, okay. Yeah, it's the nomenclature is definitely confusing. Whoa, no. Okay. So yeah, no, it's fine. No, it's right. It's right. It's right. It's right. It's right. I'm just checking something. So what we have to, okay, I see now. So over here, I see one confused with this particular thing. Okay, cool. Let me assist you in the first one. So for the first one, um, yeah, this textbook anyway. So over here, we're gonna take your normal pitch. So this is your pitch over here, right? So that's your standard. So that's your 75, plus your denim, which is 10, and we're gonna square it. Okay. Then we're gonna say minus. Now, I don't know why. Okay, then I say it's minus your this over here. Okay, which is gonna be 70 point 477. I think I'm just used to doing it a lot differently. Yeah. Okay, squared. I think that's correct. That's fine. Okay, cool. No, it's no stress. It's no stress. Okay, so which is your base circle over here? That's your base circle. Yeah. I'm used to just doing a bit differently. That's fine. And then for this one, plus obviously you'll come over here, and that's gonna be your 2 to 5 plus 10. Right? We square that guy. Just fix this up. And then we're going to say minus, of course, we found that out already, which is minus 211.431. And then it's cos 20. So guys, don't feel overwhelmed. All we're doing is finding something called the contact ratio, which tells us how many pairs of teeth are in contact. That's all. Okay, let's quickly do that. And just tell me what contact ratio you get. And don't forget to add, obviously, you know what I mean, the 10, 20, and all of that. So I'm waiting on that answer from you guys.
So there's no need for that cos 20 at the end there.
Let me check. Yeah, you're right. Sorry, my bad. Again, I'm so used to. Yeah, thanks, Milo. Because we've done it already. Yeah. Squared. Cool. Perfect. Just get a contact ratio. So what's really important here is it's just knowing what it represents, how to calculate it, and that's it. It's taking long as expected, but anyway, we'll move. So let me know once you've got the answer. I'm joining now only. We're nearly there, guys. You are around 6 weeks, and you're done with this. Done with the semester. Just you preparing. Okay. What are you guys still busy?
See, I get 1.608.
1.608. Perfect, man. Yeah. Thanks, Milo. 1.608. Again, that's an acceptable value, right? We can make a note of that. As long as we between the range of 1.4 to 2. That's what Spur is. That's what's key. But like I said, with all these new things that you might find that suppliers who have all these, but I mean, you might work in a company where this is something you have to do. But like I said, I mean, you might not. And so therefore, this is okay. So any questions with this one, guys, before we move on? Any questions? Guys, you're allowed to ask questions, you know.
Oh, sorry, sir. I was just trying to get the mic to work. I'm getting a different answer. Yeah, it's 1.32, so I'm not so sure. I'll have to look it over. So
Yeah,
forgive
yeah.
me if I mentioned, but yeah.
Yeah, no, for sure. You went out somewhere, man. Just have a look. Because I checked now in the book, it's like 1.61. So yeah, so I think Milo's right.
Okay.
But if you're not getting it, you can just email me. Then we can obviously just check your brackets and stuff. So I recommend work out that piece on its own. You know what I mean? That guy on its
Oh,
own.
yeah, I
That
can
guy
sort
on
of
its
like
own.
break it down. Yeah. Okay.
Yeah. So that's
Okay.
that's. But let me know. Let me know if you're still battling. And
All
just
right.
yeah,
Well.
excuse my handwriting as well. It maybe threw you off somebody. But okay, cool. So let's move on to the next part of the question. So it says the pressure angle and contact ratio if the center distance increased by 5 millimeters. Fine. So what we got to do now, and this is quite a common problem, and you'll notice even in the exercises, if you go through them, it'll put you in a good front. The reason why it's kind of being brought up here is that um, we're looking at there are possible ways of increasing or decreasing the contact ratio. And you can actually see how if we increase center distance, you might find the pressure angle might drop. Pressure angle drops, it affects other stuff. But like I said, this is very specialized stuff in terms of design. But anyway, let's quickly try. So we increase the center distance by 5. So what it means is your R1 plus R2 is going to be now 305, right? Initial was 300, so it's 300, it's 305. Perfect. And then what we need to do now is if that changes, so our R1, R2 is going to change. So if you recall, maybe just quickly see something. Am I missing something? We're going to need to use our gear ratios, right? So it's N1 divided by T1, am I right? Equals N2 divided by T2. Guys, make sure you remember the gear ratios because they don't actually give it. And what we try to do here is to have two equations, two unknowns, man. You know what I mean? So this would be one equation, this would be another one. Okay, so let's quickly set that on up. And the reason why, because the center distance changes, so obviously all the other numbers change. Oh, it was 15 and 45. So this one is 15, right? You can call it whatever, just say 1 for pinion, 2 for gear. Just in case. Pinion is a small gear, guys. Just to recap, gear, big one. 15 D1, other guy was 45. D2, we can do a cross multiply. So we can say this will be basically T1 over T2 will be basically 3, right? And then therefore T1 equals T2. No. This should be the other way around. Let me just see here. T2 is over here. T2's okay. T2's over here. There we go. T1's over here. Perfect. That goes there. D1, yeah, perfect. So we should get this. D2 should always be bigger. Okay, perfect. And so there we have another set. So we know that D2, obviously what we can do with that guy, we can obviously, we can divide this over here. We could also have it as, this could also be represented as, obviously, if you're going to be slick about it, you can just say a half, right? And then we have D1 plus D2. There's two versions of this, but obviously I'm using the diameter. So obviously all you have to do is take D1, chuck it in there, or D2, chuck it in there, and then solve for one or the other one. So there's your other equation over here. That's equation 2. I hope you guys are following me. Once we're done with that, we're gonna have to obviously go through this whole thing again, I think, but I'll move through it quickly. And luckily it's all recorded, so it's fine. Cool. Let's quickly get the new D1 and D2, or in fact R1 and R2. To treat this problem with respect, I'm sure it comes up a few times. I've seen it before. You can just either shout it out or you can just put it in the chat box over there. It's just lobby. Can't you guys allow people in the lobby? Cool. I think we're having the standard students now. Yeah, Milo, what's up? What did you get? So I hope everyone's following in terms of what I've done here. I think by next week we'll be doing the proper gear design.
Greetings, sir. Hold on.
Yes, Sushi.
Yeah, what are we calculating here? In up here, don't we have like is it like a new question? This one?
You ask, what are we calculating?
Yeah.
So we are calculating now what happens in the same question. We've increased the center distance by 5 millimeters, right?
Okay, so now I want to see the change in diameter.
Yes, that's correct, yes.
Okay.
And so I just set up that equation over there and I set up that equation over there. I mean, I can put up the answers and we can move on. I mean, there's not a problem. Okay, let me do that. So what you should have gotten, I'll just come straight to the textbook here. It'll be just easy for us. Is it's here. B and C. Yeah, so we get D1 is 152, D2 is 457, and R1 and R2 is that. I'm just thinking of something else. I want to make a note of it somewhere, which I want to bring to you guys. Okay, so once that is done, we then now have to restart this whole procedure from here, because no, not the whole procedure, but we have to make some adjustments. So for instance, the next step is we have to now recalculate the module. So if you remember your module is your pitch circle divided by your number of teeth. So we got to do that. So diameter for our smaller one, or in this case, is going to be 76. Okay, I have the value there. It's 152.5 divided by the number of teeth, which is 15, right? And if you compute that one, let me just use my calculator here, 152.5 will give you 10.167 millimeters. So that's my new module. Again, we're going to end up calculating the contact ratio. They wanted the new pressure angle, excuse me. And to get the pressure angle, it's quite simple. We're just going to say your R, right, if you remember that, might cause this. I'm essentially using this relation over here to find the excuse me, don't know my nose, yeah, to find the pressure angle. We then need to find, obviously, once we have a module, we need to find our addendum, right? And that's going to be easy. This is a bit debatable because, you know, your addendum is based on the table over here. So this is where I was having a bit of a problem with the textbook, or you can add over here, which is 1 times module. That'll give you 10.167. So once you have your addendum, you then can obviously compute that base circle, I believe. So we know that's going to be cool. Let me just get that down. Let me see here. Where is this now? Okay, cool. So yeah, we're gonna say just move this. I hope I'm not losing you guys here now. We're finding the new pressure angles. Cos, so it's phi. That we're gonna need to calculate this. And our initial R was what? 76.25. And then our previous one was what? The 70.47. It's over here. So that's the previous one. That's your base. Right, so that is the previous one. 70.477. That one over here. Yeah, that's the one. So now we want to see what the pressure angle is over here. Cool. So if you do that, you'll get an angle of 22.44 degrees. I'm just moving through it a bit quicker for you guys. Okay, so cool. So once that is done, you then now have to now recalculate the contact ratio. And so what I mean is that we've got a new module. You're going to have to now I'll just copy this formula here. Okay, cool. Just paste it over here. You've got to redo all of that here. Just remove this. And get a new contact ratio. So you got your circular pitch, which will be pi times m. You got a new pressure angle. That will still stay the same. And these, obviously, this will change. That will change. And then you're able to get your contact ratio. Do you guys want to do that one? Or should we move on? It seems sticky. Just got to get used to it. You guys want to solve it one?
Yeah. We have to calculate the addendum for each, depending in the gear, or they're both the same.
Yeah, so they're both the same. It's one. It's this one here. So your RP, which is the initial. What was it again? You know, this one we just solved here. the R1. And then your denim is 10.167. You then basically take that angle, right? And you're going to times it by R1 again. Are you with me, Milo? It's the same thing again. There's no new. We've done the new part basically. Or in fact, it's the 70.477 as previous. So this will be the previous value. Let me just put this here. This will be the 70.477, and the other guy, the initial base circle was 211. Yeah, 211 point. So that's my issue with this question, but nevertheless, I don't want to get into that. Your pressure angle then here will be the 22.44. Likewise over here. Your pitch again is pi times m, but your m in this case was 10.167.
Okay, just a sec. Where is the 22.4 and the 10.6167 coming from? Where are they coming from?
The 10 point?
10.167, 224.4.
Okay, that's fine.
Yeah, I
I'll
want to know.
copy this. So again, my issue with this, like I said, it's coming from table, you know what I mean? From this table, yes, it's your denim, and this is a very important table, obviously. It'll tell you for everything's related to your module, as you can see over here. So it's 1 times the module. The reason why I was having issues whilst I was solving was because of the angles. As your angle changes, you want to adjust. But I think if you look at both your full depth tooth of 25 and 20, you still have 1. So it comes from there. That's where that comes from. So it's an approximation you can make to say, 1 times the module. Yeah. It's
Did
again the module.
we have a new module? Is it like do we have a new module, or maybe we're still using that 10?
Yeah, so we have a new module, and the new module, once we found, remember we increased the center distance, so we found D1 and D2, which is that over there. We divide that by radius, by 2 to get the radius, obviously, and then now you have to find a new module, which is your pitch circle diameter divided by your amount of teeth, and then we have done that, yeah. So we found a new module. Yeah. Any more questions, guys?
Okay.
Are you guys computing for me? Yeah. It's a bit uncomfortable. It's a lot of big equations for something so small, but yeah, let me not say too much. Wyatt, we can hear what you're listening to there. Bonolo.
Do we change the addendum now as well, sir?
No, the denim is given to us. Yes, it's 10.167. I don't know what that was. Yeah. As per what Sike was saying. Yeah, there. I'll show you what you should practice, but I think in the next tutorial it'll come up anyway. It's not too bad. Just a lot, too much. Is someone calculating the contact ratio? Just confirming. James, Samkelo, Siana, are you there? Hopefully on Thursday we'll be back on campus. Okay, guys, I'm gonna give you guys 2 minutes or 3 minutes for this contact ratio. Then we're gonna have to move. I'm just gonna show you what you must prep, and then yeah. And like I said, the only reason why we're doing this is to obviously determine how much teeth are in contact. That's basically it. And now we're just changing a few things, and now we're going to be able to see obviously what happens. Is our contact ratio increase or decrease? So yeah, and it's a lot in gaze. Yeah, it's an art form on its own. So let me know what you've got. Check the chat. Nothing. All right, guys, did you get the answer? Jacob, I'm not sure, but what they said is that we return to campus on Wednesday. Not Wednesday? Yeah, the 1st, according to the message we got. But by the end of the day, we'll know for sure. Yeah, definitely. Let me just check. Yeah, because we have to submit exams on Thursday. Yeah, I'll be back on campus the 1st, so tomorrow. And they said there'll be a news flash. Okay, cool. So tomorrow we should be back. That's what I hear. Guys, what is my contact ratio? Should I just give it to you there?
Yes, so we're getting crazy numbers.
Okay, what are you getting? Okay, let me see. So for the first term, it's going to be 1 over pi times 10.167 cos of 22 point, what is it? 44. So that's your first piece over there. Your center distance, remember, was 305. Tan of that new angle you found, which is going to be 22.44. Oh, man. Just want to move this guy here. And divided by pi times 10.167. This would be, let me just do it like this. The first term would be root of RP plus your addendum, which is the new pitch. See this? Yeah, anyway, yeah, it's your, where's this guy? 76.25 plus 10.167 squared it minus, now obviously this stays the same as the previous one, right? Which is a bit strange because obviously you want to now adjust your angle, but oh, it's the base circle, so I guess that's why it stays the same. So it's a warranted move they've done there. And you're just going to square that guy. So you do the same on the other side, basically. Just want to get that other thing again. So let's try that again and then see what you get. We're nearly there, guys. We're nearly there. MED.
$1.52.
Yeah, cool. Did everyone get that? Should be 1.5 something, I remember. That's what I worked out. $1.5 what? Let's see. Thinking of sharing this other. I'm gonna. Oh, I think I'll share it with you. I think I'll show you. I'll share with you. No, I just like this one more. What did you guys get? This one. Tell me if you like this. Can you see here? That's your base circle. So that would stay the same. Then it's your complete outside diameter. Then your pitch would be kind of like halfway through the teeth. That's your pitch circle. Your denum is up there. Then your D-denum is at the bottom, which will be the whole tooth height. But that's all coming from. Let me just see. I like this one. This is my favorite one. Base circle. The clearance is that small piece there, right? Yeah. And after that, your addendum and dedem. I think I should send this one. And what is the contact ratio here? How many teeth are in contact here? Who can tell me? Who pairs of teeth? I'm gonna share this one with you guys. Okay, so what do we get for the contact ratio? Do you guys get it?
Yes, sir. 1.52.
Cool. Yeah, that's perfectly fine. So what we found that when we increase the center distance, we have less contact with the amount of teeth. Yeah, so that's that. Okay. Then what I want to just show you what you wanna probably practice. Obviously for my prescription, before we continue, let me just share. I think the TAT will cover some of these questions anyway, so if we do it now, I kind of sort it out. But I am speaking under correction. We're not far, guys, and once you go over Spur, helico's fairly the same. It's just a few adjustments. We're getting to the main stuff now. So like over here, if you could do maybe I'm looking now, where are these ones? We're not there yet. Just want to see. Problem 10.9. I just want to see something here. So these are all important. And yeah, definitely these as well. But we'll get to these ones. Okay, cool. So yeah. Like from okay, yeah. So 11.3 is decent. Anything where you're seeing contact ratio, that's what you want to focus on. But 11.3 is good. I recommend doing that one. 11.9 is also good. Doing that one. And yeah, so there's a contact ratio as well at 11.9. And then yeah, I think that's that to 11.3 and the 11.9 would be good. Yeah, I think that's gonna suffice for you guys. But anyway, let's move on. So now where I am now is the bread and butter, or the second bread and butter of gears. So this you must absolutely know. Anything from here is like this is it. So make sure you understand the following chapters I'm talking about, especially in the so-called next final exam or whatever coming up. Make sure you. So gear trains, it's covered in mechanics of machines. You can go over these things again yourself. I'm not focusing on this. We call it self-study. Should have done gear trains. So you can go over that. But this is where we are now, right? And that's going to be gear forces. Now, I just want to start off over here. Let me start off over here. So on that point where the two gears meet, and what we're looking at here is now, we looked at, you have a motor and you have a shaft and then you have a gear, and we're looking at how do we find that exact force which is producing these motions on the gear. And this is very important because it actually helps you to understand, even when you're talking about shafts and bearings, it's those things. But nevertheless, so we have a reaction force, obviously, where these guys are touching, right? The gear and the pinion. Fine. Now, when you split those two forces with the pressure angle, you'll notice there'll be a force like in the horizontal, and there'll be a force on the vertical, right? In fact, the force generated by this gear, right, is these ones over here. It's this on that. So this is a bit strange, but anyway. So what are those forces, right? Your first force is your radial force, right? It's the force separating the two gears. And then as the gear is turning, there's a tangential force. And the resultant of that two forces will give you your normal force or your pressure angle force, which is this over here. So I'm just going to recap that. So on there, on the tooth, on the pitch circle, which is very important, you'll notice you have one force Ft, which is causing that rotation at force times distance at torque. Then we have the radial force, right? And the radial force is essentially the force which is separating the two gears from each other, right? If you think about it as they push away. One is turning and one is pushing away. And for us to compute that, right, it's essentially components of these two forces. If you can think about it, it's Fn. One is going to be the horizontal component, which is going to be Fn cos theta, right? One is going to be the vertical component, which is Fr, right? Sorry, Fn sine theta. So it's Ft and Fr. But you have another way you can actually do that by, if you put this in terms of Fn, so it'll be Ft divided by cos theta. You take that guy, you chuck it in here, and you get another equation called Fr also equal to Ft tan theta. So yeah, so that's the forces. Obviously, your linear velocity is your standard pi with dn divided by 60, not 12. We're not talking about feet per minute, right? To be aware of that. That Ft is the force which is producing the torque, right? So we know it's going to be Ft, right? It's a tangential force times d over 2. Alternatively, you can substitute it into that over there. Of course, if you're going to find the power, we know power is simply equal to force times velocity, or torque times omega. So it's entirely up to you. We don't really need to know these horsepowers and stuff. We're smart enough to figure out power equals torque, power equals 2 pi n divided by 60, right? I think we all can do that, or force times velocity. But the important parts, right? Again, There's your radius, your base circle, right? On the tip of the tooth, this is at this point, which I'll revert back to. Let me go back. You see that point there? If you isolate that point, that pitch point, so they say, just there, right? That is where the forces come from. And we have three forces essentially, or two forces on the gear, and its respective resultant. And in this case, it's your tangential and your radial force. Now, if you remember, we talked about that on a shaft, what produces radial forces? We said gears, belts, case in point over here, right? We have a radial force on the shaft. Therefore, we know journal bearing or ball bearing, depending on what type of roller bearing we're going to need to handle that. And now, when we're looking at actual helical gears, we'll notice there's an actual force. So therefore, we have to look at a different way when we're using that. So I hope everyone has gotten this part of it. So what I want you guys to do now for me is I want you to find the forces. See, this question you could actually make gears, bearings all in one question. That's like the highest level type question. But I want you guys to use this information here. Don't ignore all the other stuff. And I want you to find all the forces on the gear. So what I'll do for you is copy those formulas so that you have it over here. And sketch it yourself, right? I want FT. Maybe I should post this as well. So just have some guidelines. And we'll do this as a class, and then we can end it here. Then we can start immediately next time with our first example. So again, there we have over here. Again, on the screen, you can see here, gear turns, you have the tangential force, and you have a radial force separating the two gears, and the resultant will be that one. And that's when the pressure angle is so important. Okay, so you just need information basically in the top section, right? So this can give you your torque. From your torque, you can obviously find something here. Though I don't want to mention too much. From that, you can compute each one. So from you guys, can I get my torque? Can I get my tangential force? And can I get my radial force? You guys with me? Is there any questions?
Yes.
Yes.
Yeah, it's like I was looking at FR equal to FN sine phi, equivalent FT tan phi. So I was sort of just a bit confused as to how did it become FT tan phi from like FN sine phi, which is FR. So I was trying to.
Are you saying this one here, CK? This one here? Or this one? That one?
Second formula.
This one? This one? If in sine,
Well,
no?
don't see the point.
So
It's
where it's
like
coming from, CK, is that we have a resultant Fn, right? Of the two gears in contact. And all we're doing is taking two components. One cos, which is that one, the tangential force, which is producing that torque. And then we take another component, which is the sine one, which is the radial force. And then it's separating the two gears. Yeah.
Okay, so it's some kind of a geometric thing.
Excuse me?
It's geometry.
Yeah, but of trigonometry, yes. Of components or vectors. Okay. Let's quickly get those forces. No? So you don't need all that information. Just focus on. I just thought I'll make a small one just to see if everyone is on the same page. So first, get me the torque. Welcome to mechanical engineering. gonna get better. Okay, so what is my tour, colleagues?
238.7.
238.7, huh? Okay, where is this now? I'm on my slides. No? You trust me, look. 238.7. Let me write it here. Let me use a different color. 238.7 Newton meter. So from that, I'm sure you can easily find FT, or you can find FN. Pressure angle is 20 again. There's so many things. I mean, obviously, it's many ways. If you find FN, everything else will be easy, obviously. Then you can just find out this easy. Okay. You're nearly there, guys. Let's just get this done. Then, yeah, I'll see you again on Thursday. Okay. What did you guys get? So what I get for my radio force, FR?
So I got 1158.4.
Okay, 1158.4. That's Newton's, right?
Yes, sir.
115. This is for radio, right?
Yes, sir.
Yeah, and then for your tangential force,
3182.6.
31. What's it?
3182.6.
Why it's so big, man?
So the one below is 1158.4.
Oh, 1158.
58.
Oh, okay. Yeah, there we go. That makes sense. Okay, let me just, yeah. Okay, cool. I hope everyone has gotten that. 1158. And there we go. 1158.4. And like I said, you can easily just take that force.
The one
times
above is, oh yeah, that's correct.
Yeah.
It's fine.
Now you can take that and times it by the pitch circle divided by 2, and you should get exactly the same total. So yeah. Okay. All right, guys. I think that's it for today. I will put the link up later on. Like I said, use the time to push the project. Just do 2 of these examples. You can just go over the one we did. Make some notes on contact ratio, interference. Nothing too big. The main meat is these type of stuff, the gear forces, which is going to be. Highly recommend you focus on this. So hopefully I'll see you on campus on Thursday for this. Then we're going to be looking at the Lewis formula, and then which is basically the bending state of the tooth. Imagine that. Then we're also going to be looking at the wear. Where's that? Where's my wear now? Like this is the AMG, but I mean the wear, which is over here. It's well. And then we should also look at the so-called AGM standard method for designing gears, which kind of makes up the main body of work. It's not tough, it's just a lot. And if you go through one example with decent notes, and yeah. And the last thing I want to say is that, guys, if you are developing your formula sheets and if you want to find out if it's correct or should I add anything, you can always email me when you see me. It's, sir, should I include this? Should I not include this? Yeah, so just let me know. But for now, just go through the example, do that 2 stuff. Then if you want to work ahead, you can squeeze in this one. We will do this one tomorrow. I mean, on Thursday, then I will be giving you guys 2 more additional examples based on this, which I believe will help you. And then obviously the ones in the textbooks are all at the exam level, so you know exactly what to prepare for. Yeah. All right, guys, thank you, and I will see you on campus on Thursday. Cheers.